about set theory. And what's the meaning of X block sets? And the first one we
How
have
will
here.
I do that? Let me pick the
Good day, everyone. You're welcome to the type of sets. We started type of sets last week, and we are here to continue it this time. We have subsets as in type of set here, and when we're talking about a set A is said to be subset of Q if and only if all elements in A are contained in Q. What do we mean by this? You have a set that has its own element, but there is another set that has all the elements from that set in its own, even though it contains more than all the sets in the first set. So you said the first set is subset of the second set. And how do you identify that? Let's take for example, we said A is equals to open parenthesis 2 comma 5 and close parenthesis, and we have Q to be equals to 1, 2, 3, 4, and up to 6. We can see that all the elements we have in A are also contained in C. Because of that, we can say A is a subset of Q. Why? Because all the elements in A are also in Q. And because of that, we represent it in this form, saying A is a subset. This is the symbol for the subset of Q. Or you can turn it in other round by saying Q as a subset of A. Let's go on. Another type is universal sets. Universal set is somehow similar to a subset and the big set, but the difference between them is that when we're talking about universal set, it is a set that has all the elements that all other subsets has in them. Let's take for example, you have a set to be equals to 1 comma 2, you have another one to be equals to 3 comma 5, and you have another one to be equals to 4 comma 6. But a universal set we have each and every element in all other subsets in it. Take u is now equals to 1 comma 2. 1 comma 2 is set A, you have it in it already. You have 3 comma 4 comma 5, and B is 3 comma 5. That is, you can still find the element of set B in this universal set, and C that was equals to 4 comma 6 was still there also. You have it to be 4 and 6. So this U here is known as the universal set of all the other sets that you have. Therefore, it is represented using U. Another type of set we have here is set difference. It is represented as A minus B. It does not have to be A minus B alone. What I'm trying to tell you is you use minus sign, which is the difference sign in normal mathematics, to represent the difference between one set and another set. That is, you can still have P minus Q as long as your sets are P and Q. So what does this statement mean? This means that you're looking for the elements that you can find in the first set, but you cannot find them in the second set. If it is A minus B, you're looking for the elements you can find in set A, but you cannot find them in set B. And I mean you're using P minus Q. You're looking for the elements you can find in set P, but you cannot find them in set Q. That means you're looking for the difference between the two sets. And let's take for example, you have your A to the open parenthesis 1 comma 3 comma 5 comma 8 close parenthesis, and you have your B to be equals to open parenthesis 1 comma 5 close parenthesis. If you're looking for the difference of A minus B, that means you're looking for what you have in A that you can't see in B. You have 1 in A and you have it in B also, it is not included. But you have 3 in A and you can't find them in B. Then 3 is the first element that you can find in A and not in B. So it will be the first element for the difference of the two sets. And 8, which you can find in A but you can't find in B, is the second element. Because the 5 you have in A, you also have it in B. That means your difference of A minus B will be equals to 3 comma 8 as the element for the set. Note, A minus B is not equals to B minus A. Just like in normal mathematics, if you have 5 minus 3, you have it to be 2. And if you have 3 minus 5, you have it to be minus what? Minus 2. Thank you very much. It's the same thing as set. The value you get for a minus b is not the same with the value you get from b minus a. Why? Because b minus a is telling you that what are the values you can find in set b, but you cannot find it in set a. Now let's take this above one for example, the one we use for the a minus b. Let's use it again. If you're looking for b minus a for the above example, your answer will be 0 because you have a null set. Why? All the elements you have in set b, you also have them in set a. That means there are no elements that you can find in b but you can't find in a. Because of that, your answer will be a null set. But let's take for example, if you have 1 comma 2, let's say you have a to be equals to 1 comma 2 comma 3, and you have b to be equals to 1 comma 2 comma 3 comma 4 comma 5, and then I ask you b minus a. In this case, let me give you some time to do comma 5, then you have a close parenthesis. They ask you that what is b minus a, that is the difference between set b and a. Take some time to try it and let me see your take some time to try it and let's see if you get the answer. Welcome back. Your answer to this is a. Your answer to this is b minus a equals to open parenthesis. You have 1 in a, you have it in b. That means you have it in both. That's not the answer. You have 2 in b, you have it in a also. That is not the answer. You have 3 in b, you have it in a also. That is not the answer. But let's say you have 4 in b but you can't find it in a. So you have your first element to be 4, comma. You have 5 also in b and you can't find it in a. You have comma 5. That is, your b minus a will be equals to 4 comma 5 as the element. Another type we have here is complement of sets. The complement of set A is or are elements in universal set but not in set A. What do we mean by this? If A is to have a complement, the complement set of A will be the values you can find in the universal set but you cannot find them in set A. I give us example here. We say u is equals to open parenthesis 1 comma 2 comma 3 comma 4 and comma 5, and we have our a to be equals to open parenthesis 1 comma 4. If you are looking for the complement of a, which I've given you the formula here, you said it's u minus a, that is the difference between the universal set and the set A. And remind, I told you earlier that when we are looking for the difference, we are looking for the values you can find in the first set but you cannot find them in the second set. And let's go on. If you're looking for the complement of set A, which is represented as a raised to power c or a prime, you will be having, you have 1 in set in the universal set and you also have it in set A. So 1 is excluded. You have 2 in the universal set but you cannot find it in set A. So the first element you'll be having in set A complement will be 2, comma, you have 3 in the universal but you can't find it in set A, then 3 is included. You have 4 in the universal set and you also have it in the set A, so 4 is excluded. You have 5 in the universal set but you cannot find it in set A, that means 5 is also included. These are the values you'll be having, these are the elements rather you'll be having for the complement of set A, and you have the formula to be u minus a.